So last part here, we're going to use your CAS program that you just built, and we're going to use it to solve the Euler's questions that are on the back of your worksheet. Now we've actually already done one of them because I showed that to you when you programmed your CAS. So that was finding y3. And when we did that for cos x, we had 1.29751. 1.29751, and we found that by hand as well, so we've done that one. So next one we're going to do here is the derivative, and it's 1 on x squared is the derivative. So what we have to do in where you've got your Euler program opened, we need to define the derivative function. So again, I'm going to do control matrix as a define, and it's 1 on x squared. I'm going to just use brackets, so like that. That's my derivative. And I'm just going to move this over so we can actually see, move this over, what we're looking at here. We've got our initial x value, our initial y value, and we're looking at y4, which means 4 lots of this step size. So I'm going to type in Euler 2, bracket. Okay, the first thing is the initial x, that is 1. Okay, so 1, comma. The initial y is 0, so I'm going to do 0, comma. Now we have to decide where we're going to finish, what c is going to be. Now we know that our initial x is 1. We need 4 y's. This is y0. We need y1, y2, y3, y4. So we actually need x1, x2, x3, and x4. And remember, to get these x's, what we have to do is we have to look at iterations. So we have to look at, what happens as we move up by this step size. I'm just going to move this over so you can got a bit more room. Okay, so let's look at the first one is going to be the first step size. Adding a 0.01 is 1.01. Adding another, remember that each time we go up it's adding h. Adding another 1.02, 1.03, 1.04, and that's because our step size is 0.01. So for y4, which is what we want, this is the x that you need to get to, 1.04. So I'm going to use the program. I'm going to type 1.04 because that's where we need to get to for x, and the step size 0.01 goes in, and we push enter. And I'm just going to expand this so you can see, and expand this over a bit. So you can see here that you've gone 1, 2, 3, 4. You've gone to 1.04, and you can see the values for y. So I'm just going to squish that a bit so we can actually write them in. So we've got 0.01. Now you don't actually need all of these, you know, but we start at 0. But I'm just going to write them here so you can see what's happening. I'm just going to go to 4 places after the decimal, that's enough. y2, y3, 0.0294, and y4, which is 0.0388. So what we've done here is we've actually found y4 to be equal to 0.0388 by using Euler's method. And if you wanted to, you could put the additional ones because you have it. Okay, so that's finding y4. So the last one, have a go at it. If you want to, you could pause it and then have a go at this last one. See if you can do it, and then you can watch the solution. So last one here, we've got 1 on cos x squared. I'm going to type that in. Remember, you have to define your new function, which is 1 on cos of x squared. I'm super careful with brackets, I use them everywhere. And we know our initial x is 0, our initial y, so we've got x0, y0, we've got our step size, and they actually tell us the x that we're going to stop at, so they actually tell us c, and we know that this is our g of x. So when we use our method, when we use our Euler program, remember it's x0, y0, h, c, and then h. So we're going to put all that in. It's 0 for both of the initials. We need to get to 0.3, and the step size is 0.01. So Euler 2, 0 for both. We need to get to 0.3, and the step size is 0.01. Now you can see this is a very small step size. It's going to go for a long time. Okay, and imagine doing this by hand. It would be terrible. It's very long. And you can see here at the end, you've got your coordinates that you were interested in. So it was asking you here for the value of y when x equals 0.3. And you can see here that from your printout, we know that when x is 0.3, y is 0.300224. So that's really telling you your y after all of those iterations using Euler's method. So make sure that you're able to use this method by hand, so using a table like I did in the first example, and also using your calculator program.